Hi guys, I'm going to do a video here for our Chapter 2, Section 1 that we're working on. And if you're setting up your Cornell notes, be sure you pause the video if you need to and kind of copy this down so you have nice, neat notes. But here's the essential question that we're going to try to answer in this video. How can you use an inequality to describe a real-life statement? So we're going to talk about what's an inequality and how can we use it to describe something in our real life, in our real world. So that's kind of going to be our focus. Now, for some of you, this might not be new information, and for some of you, it may be. So we're going to do a little review first. So on the left-hand side of your Cornell notes, we're going to write inequalities as our main idea. And then next to it, what we're going to do is we're going to build a table. We're going to talk about the inequality symbols and the key phrases. Those will be kind of the two things we're going to talk about. So the symbol and the key phrases. Again, if I go fast, just pause the video so you can write all this down. So there's a few different types of symbols that you need to know. So in my table, I'm going to put a few different lines so we have some spaces here. And I'm going to make it a little bit bigger like this so that you can have a little room to write also. And let's kind of go through these inequality symbols. So here is the first one that we're going to put in our chart. It looks like this. We call this symbol the less than symbol. Key phrases would be less than. But sometimes when we're like reading a situation or talking about something in the real world, we'll use other descripting words, basically. Fewer than would be kind of like less than. So fewer than would be another key phrase that I connect with this symbol. Less than, fewer than. The opposite of this symbol is the greater than symbol. It goes the other direction. So we say greater than is a key phrase. But another key phrase you might look for, like if you were reading like a story problem or you were talking about something in our real life, is you might read the words more than. And don't forget, more than is the same as greater than. So more than, greater than, both kind of go with that same symbol. Then we have when we take the less than sign and we put the little line underneath. And that little line underneath is the equal sign. So this little symbol is the less than or equal to. Less than or equal to. And when you're reading a story problem or using other phrases, something you might see is the word at most. If I say at most, I have 5 pencils in my locker. At most. That means I have 5 pencils or I have less than 5 pencils. Maybe I have 4 or 3 or 2. So that's less than or equal to, at most. Another key phrase you could write down for this one is no more than. I could say, hey guys, in my locker I have no more than 5 pencils. Well, that means I could have 5 pencils, but I can't have 6 or 7. I have to have no more than that. So I have to have less than 5. So no more than's a key phrase that connects with this one. And then the opposite of that symbol is the greater than or equal to sign. So we say greater than or equal to. Those little lines underneath are part of the equal sign. Other key phrases that you might look for would be something like is at least. So if I said, in my bank account, I at least have $100. At least have $100. So I might have more. I might have $110 or $120, or I might have $500. But at least I have 100 or something greater than that. So that's a key phrase. And then I also could say is no less than. So like my bank account has no less than $100. Again, that means I could have $100 or I could have greater than that. But I can't have less than, is no less than. So again, that's another key phrase. So this is something, like in my notes, if I was writing this down, I would make a nice chart of this because people tend to forget like what words connect to which symbol. So this is just kind of an easy go-to chart that you can look at to kind of help remind you which one's the right symbol to use. Now let's try some problems. Let's talk about what a mathematical sentence is. So a mathematical sentence would be something like this. B plus 3 is greater than 22. Go ahead and write that down. B plus 3 is greater than 22. This is what we call a math sentence. But we could totally translate this sentence. I could switch it into an English sentence. So I'm going to do a little translation here for a moment. And what I'm going to do is I'm going to draw an arrow under each part of my math sentence, starting with the B. The B is just standing for a variable. It's a number, really. So it's a number. If I had to translate it into English, I don't know what number it is. Not yet. I can figure it out. But it's a number. And that plus sign, when I translate it into English, is the word and. So I have a number and I have 3. So a number and 3. Now I already know how to translate the symbol. The little symbol is the greater than sign, so is greater than. So my translation looks like a number and 3 is greater than 22. So on top, in purple, we have that math sentence, and down below we have that English sentence. A number and 3 is greater than 22. This is why I like math. Math is shorter. I like the B plus 3 is greater than 22. Writing out all the English words in the full sentence seems like a lot of work to me. But that's that translation. You want to be able to go back and forth. So let's do an example. Let's try a problem now. That's kind of enough talk about inequalities. Let's get into something. So here's our first problem. We're going to translate this English sentence into a math sentence. So it says a number Q plus 5 is less than or equal to negative 7.9. We're not actually doing any solving yet. We're just translating. So a number Q, I'm going to focus on that part first. A number Q, okay, so I have Q, plus 5, okay, so it means I'm adding 5, is less than or equal to, oh, that's that symbol, less than or equal to, negative 7.9. Negative 7.9. There's my math sentence. I'm all translated. And then later on, we're going to solve it. But for now, we're just rewriting, basically. Okay, your turn. You're going to try. So I'm going to give you a problem, and you're going to pause the video, and you're going to see if you can do this on your own, because you want to get a handle on this. So there's 2 of them, actually. I'm going to give you an A and a B. A says a number X is at most negative 10. Translate that to a math sentence. And B says, twice a number Y is more than negative 5 halves. Again, translate that one. So pause the video, take a minute to work on both of these, please. Okay, you're unpausing the video now. You have translated both of these into a math sentence and you're ready to check your answer. So a number X is at most negative 10. That means X has to be less than or equal to negative 10. Because at most means less than or equal to. So there's that math sentence. And then for part B, twice a number. Twice, what does twice mean to do? It means to double something, to times it by 2. So twice a number Y is more than negative 5 halves. So we're going to do 2 times Y, twice Y, is greater than negative 5 halves. And there's our translation. I'm hoping that's what you got too. If you didn't, look for your mistakes. See if you can figure out what did I make a mistake on and how can I do that differently next time. It's always good to learn from our mistakes. Okay, example 2, we're moving on. Okay, next problem. This is what we're going to do. Tell whether negative 2 is a solution to the inequality. We're going to see if negative 2 is a solution. It's kind of like we're going to check our answer. And here's our inequality. We're going to do 2 parts. We're going to have an A and a B. For A, we're going to check if Y minus 5 is greater than or equal to negative 6 is our inequality. Now, we're supposed to tell if negative 2 is the solution. So the plan is we're going to put negative 2 in there and see if it works. So right where that Y is, I'm going to draw a little arrow, and I'm going to replace it with negative 2. And I'm going to do negative 2 minus 5 is greater than or equal to negative 6. Now I just got to check my math. I got to do negative 2 minus 5. So negative 2 minus 5 is negative 7. And my symbol says greater than or equal to negative 6. So now you have to ask yourself, is this true? Is negative 7 greater than negative 6? I hope you're shaking your head and saying no. Yeah, no, false, doesn't work. So negative 2 is not a solution to this problem. It does not work. I'm going to slash out the greater than or equal to sign because it's not true. So I put that red slash through it. And I'm going to say negative 2 is not a solution. It did not work. We tested it. We tried. It didn't work. Let's do that again. Let's do that on part B here. but new equation or new inequality. Negative 5.5y is less than 14. Okay, same story. We're going to replace the y with negative 2. So now we have to do negative 5.5 times negative 2 is less than 14. We're going to multiply those together. With your calculator is fine if you need your calculator. If you can do it in your head, that's great. Negative times a negative is a positive. 5.5, if you double it, times 2 is 11. So now we have 11 is less than 14. And again, you got to think, is it true? Is 11 less than 14? Oh, totally, right? Like when you stop and think about it, this one's true. So absolutely, negative 2 is a solution to that inequality. It worked. It worked in that inequality. So we're just testing numbers to see, do they work or do they not? And seeing if it's true or false. And I'm going to have you guys try some also and kind of see if you're getting the hang of this. So here's your you try problem. Tell whether negative 5 is a solution to each of the inequalities that I'm going to show you down below. So I'm going to give you 3 problems, an A, B, C. You're going to maybe need to pause the video and write these down. But your job is to test negative 5 on each of these inequalities. So please pause the video right now, write them down, see if you can solve these, and then check your answer when you're ready. Okay, you ready to check your answer? Have you paused the video and unpaused the video? I hope so. Okay, so we're going to look, is negative 5 a solution? So let's check out the first one, part A. We'll put negative 5 in there, and we'll add it to 12. That makes 7. And you end up getting 7 is greater than 7. Is 7 greater than 7? No, it's equal to 7. So this one's false. It didn't work. Negative 5 is not a solution. Not on that one. Let's try the next one. We'll put negative 5 in. Now we got to do our order of operations. We're going to multiply first. 2 times 5 is 10. The negative makes a plus 10. It makes it positive. And 1 plus 10 is 11. So 11 is less than or equal to negative 9. Again, think about it. Is 11 less than negative 9? I don't think so. That's another false. So it didn't work on that one either. Not a solution. Try the last one. Put negative 5 in and divide it by 2.5. Negative 5 divided by 2.5 is negative 2. Is negative 2 greater than or equal to negative 3? Well, it's not equal, but it is greater. Negative 2 is better than a negative 3. So yeah, true, totally on that one. Negative 5 is a solution on the last one. So didn't work on A and B, but it does work on C. So again, one of the things you should always do is after you do the you try problem is you should go through these and see if you got them right. Like double check your work, and if you made a mistake, try to figure out where that mistake happened so that you don't do it again when it's a test or a quiz or something important where you're being graded or maybe needing to perform. So go ahead and try to figure out those mistakes. All right, so I'm going to add one thing down to the bottom. At the bottom of each of these, I'm going to write negative 5 is not a solution, negative 5 is not a solution, and then for the last one, negative 5 is a solution. Just so whoever reads my work has a clear understanding that I get it, that I've answered the question, and it's very clear. Kind of look at my work too. You see how I'm kind of going in steps and I'm organizing it? That's what you want your work to look like too. It's something we do in algebra a lot, is we kind of go step by step by step by step. And we clearly define our answers. So notice I kind of put my answers in boxes down at the bottom. Negative 5 is not a solution. It's very clear. So I just really want whoever reads my work to clearly see if I get it or I don't get it. And that's the idea of organizing our work. All right, guys. So we're moving on. We're doing example 3. And example 3 is this. We are now going to graph the solution. We're going to do some graphing. We're going to graph x is less than 3. X is less than 3. So here's how we graph an inequality that has one variable. What we like to use is we like to use a number line. So we are going to be using a number line to do all of these one variable problems. I'm going to draw a nice number line. I'm going to put 0 right in the middle. I'm going to go like 1, 2, 3, 4, 5 on one side, and then negative 1, negative 2, negative 3, negative 4, negative 5 on the other side. It's important that your number lines are nice and neat. So I like to use my ruler, or on graph paper, I like to use the lines on the graph paper to make my scale. I don't want it to be sloppy and just like random numbers thrown on there. You want it to have some neatness to it. But the important number that's on the line is 3 because x is less than 3. So my focus area is right there at 3. I'm going to circle it. Then what I'm going to do is I'm going to think about 3. I'm going to think about both sides of it. So I'm going to pick two numbers, something on the left and something on the right. I don't really care what we pick. We can pick anything that we want on the left and right. But we're just going to test them. We're going to test both sides. So to test, I'm choosing 5 on the right. I could have done 4. I could have gone up to 6, 7, 8, 9, 10. I can choose anything I want. But all I have to do is see if 5 passes the test. Is 5 less than 3? Think about it. Is 5 less than 3? No, 5 is not less than 3, so that one fails. Now test the other side. Pick something on the left-hand side. Anything you want. It could be 2, it could be 1, it could be 0. I'm picking -1, whatever you want to do. Is -1 less than 3? Yeah, -1 is less than 3. That is true. Yes for that one. So what I get to do is I get to take my colored pencil or my highlighter, or sometimes I just take my regular pencil and use the side of it, and I'm going to shade my number line nice and dark off to the left. And I'm going to make a big arrow on the left-hand side to show whoever reads my paper that it is the left-hand side that passes this test. Now, I'm not 100% done. I have one more thing I got to do. And the last thing is that I have to test 3. I have to put 3 in there. Is 3 less than 3? Now, 3 is equal to 3. So because it doesn't pass and that one fails, I'm going to leave on my number line an empty hole. I am not going to fill in the dot on 3. It's going to stay empty. This is it. This is my answer. This is my number line for this solution. If it had been equal to 3, I would have filled in that hole and made it solid, but not in this case. So let's try an example 4. This time, we're going to graph the solution for m is greater than or equal to -2.5. Throw a decimal in there. M is greater than or equal to -2.5. So again, we set up our number line. We put 0 in the middle. You might have to pause the video if I go fast on some of this stuff. But you got to set up your scale on both sides. 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. You got to get all those numbers on there. And it's the most important number that we have to focus on, and that is -2.5. So I'm going to very carefully go to my number line, and I'm going to circle -2.5. Then I run my tests. I'm going to test both sides. I'm going to look at the right, and I'm going to look at the left. Any numbers that I want to test work just fine. I'm going to test 2 on the right, and I'm going to say, is 2 greater than -2.5? Oh, totally. 2 is greater than a negative, so that one's true. That one's a yes. Which already tells me when I grab my pencil or my colored pencil or my highlighter, I'm going to shade my number line off to the right. And when I'm actually doing this on paper and not on my computer, I do like take the edge of my pencil and really shade it in nice and dark and solid so people can see all the numbers to the right work. If I try to test the other side of the number line, like if I pick -4, it's going to fail. Only one side can pass. So -4 is not greater than -2.5, so it's a fail. But I'm not totally done. I need to test the point too. I need to see, is -2.5 greater than or equal to -2.5? And yeah, -2.5 is not greater than, but it is equal to -2.5. They are equal to each other. So I'm not leaving this graph empty this time like the last example. I'm filling it in. I'm going to make a nice, dark, solid hole on my number line. And that's going to be my solution. So if you've got that, yeah, it's equal and it works, then fill it in, make it dark. Unlike the last example, I left it empty and made it an empty hole. All right, I hope this is making sense to you guys. I'm going to have you try, and we'll kind of get an idea here. So here's your you try. I'm going to have you graph each inequality that I show you on a number line. So you are going to graph these two things on your own number lines. You're going to make two number lines. One of them is going to be for z is greater than or equal to 4. And your other number line is a little trickier. I gave you a harder one. -1/2 is less than t. So this is the time where you need to pause the video, stop the video. You need to try both of these and see if you can make a nice number line. Okay, good luck. Okay, let's check some answers. You've got two number lines. You should be unpausing the video. You should have your number lines completely done. We're going to see if you did them right. So for the first one, z is greater than or equal to 4. You should have a solid point on 4. It should be solid and then shaded to the right. All those positive numbers, 5, 6, 7, 8, 9. So shaded to the right. And then for the second one, a little trickier because I put the variable on the right-hand side. But same thing, you're going to test your points. Here's negative 1/2. It's going to have an empty hole. I'm not going to fill it in. And shaded to the right, everything on the greater than side. So the positive numbers. That should be your solution. All right, guys, so that's really all I got for you. And I hope you kind of took away like a little bit of a refresher on what the symbols are, how to translate a math sentence to an English sentence, and backwards English to math, and also how to graph them on a number line. And we're going to practice this in class too, but thanks for watching, and I hope you took some nice notes.